please. Ready? Thank you so very much. All right, we're ready. So, today, the second half here, just for a few minutes, we're going to talk a little bit of review about ellipses and circles. And we did ellipses and circles way back in chapter 3 when we were talking about our families of functions. And remember we had like the square root family and the absolute value family and the parabola family. And then we talked about circles and ellipses and we said they weren't functions. Remember that? Because they failed the vertical line test. If you drew a circle and you laid your pen on it, it would touch in more than one place. So, even though they weren't functions, we did look at them briefly in chapter 3. In chapter 9, they bring them back a little bit. And so we're going to just do some review. It'll also be really helpful for us on our final exam here coming up in just a couple weeks. But ellipses and circles are essentially what we call conic sections. They're not functions. They're conic sections. And essentially that just means they're part of a cone. If you remember your geometry, we could draw a cone. A cone kind of looked like this. And sometimes you had double cones. They kind of came up like this. And then there was a cone on the bottom as well. And essentially a circle is a cone, is a part of a cone that we would get if we just cut the cone like right off. Because you'd have a circle up here at the top, and you'd have a circle here if we cut through there. An ellipse is what we'd get if we cut it on an angle. So like here, our shape would be a little bit more long. We could get one that was more tall instead of long. We also can look at parabolas in that way and hyperbolas in that way. We are just not going to do that right this minute. We'll get to those later in the chapter. But by definition then, a circle is just a part of a cone that has a locus of points. A locus is a really nice math word for a group. And we talked about this when we talked about our circles. We said it's a locus of point, or a bunch of points, a group of points, in any plane. And then sometimes in geometry we talked about like plane P is this plane, like on my piece of paper. That are a constant distance, r, which is our radius, from the center point. So essentially what they're saying is if we had some center point r, and everything was 4 away, if this was 4 away, 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 all of these were 4 away, we just could keep going and going and going and going and going until we had so many points there that it would be all packed in together. And we'd have all of the points that were available, and we would have a circle. So that was a really big, long way to define a circle. All I guess you need to remember from that is a circle has a radius that's r. And in any direction from the middle to the outside, those r's are going to be the exact same, essentially. So here was my circle that I drew the other day. And no matter where I started at the center and I went out to the sides, my r's were all the same, my radius is the same. Back in chapter 3, we had this equation for the circle. So, if you are one of those people who thinks, I have all my notes already done, I don't really need to write this down again. We wrote this down in chapter 3. And it's already online, because I just finished doing that while you were working on the first problems. So if you don't want to write it again, don't. You already have it, or you can print it off. The only thing we had to write today was that distance formula. But we have the equation of a circle. If the center of my circle was 0, 0, then we just said it was x squared plus y squared equals r squared, where r was the radius value, so whatever this was. So if this was 5, then we'd have x squared plus y squared equals 5 squared, which would be the same thing as saying x squared plus y squared equals 25. So if we wanted to write an equation for a circle with a radius of 4 and a center at 0, 0, using that information we just had above, we would say that was x squared plus y squared equals what? If the radius is 4
squared.
It would equal x squared plus y squared equals 4 squared. Jackie, what's 4 squared? 16. So we could just write that as x squared plus y squared equals 16. So the equation for a circle that has a radius of 4 and that's centered at the origin, 0, 0, is just x squared plus y squared equals 16. And the 16 we get by just taking the 4 and squaring it. Questions about that? Should we review? Okay. Then, we also talked about, when we were doing chapter 3, circles that were not necessarily in the center. So if we had a circle that was not necessarily in the center, we wrote down this equation, and we wrote this down in chapter 3 as well, so you would not have to write it down again today, because you already have. But, if we have some center other than 0, 0, any center other than 0, 0, we just are going to plug our center values in next to our x and our y. So we have x minus h squared plus y minus k squared equals r squared. We're going to talk about the point, or a line rather, that just touches the outside edge of a circle. You had those in geometry as well, tangent lines. So a tangent line, if you have a circle, is a line that touches that circle at one point on the outside of the circle. It can't cut through the circle, then it would have a different name. And last thing for today, also when we did chapter 3, we talked about the standard form for an ellipse. And if you notice, the standard form for the ellipse, the x minus h squared and the y minus k squared is exactly the same. The radius changes here because remember, an ellipse is one that could have a different width than height. So this might be 3 and this might be 10. Hold on for me, guys. We'll go over it here and then we'll start the problems tomorrow. So our center is h minus k, or h and k. Our horizontal scale, how far out it goes, is going to go down here with my A, and how far up and down it goes is going to go here with my B. Again, all these notes are online, so focus is 2 points inside of that ellipse, so you'd have an ellipse, and you'd have a point here and here that are your focus. The major axis is the long one, the minor axis is the short one. I want you, before you leave today, to write down this assignment from page 503, because we're going to start with it tomorrow. We're not going to tell you what it is again. So take a moment. When you come in tomorrow,